You know, when we think about climate change, our minds usually jump to things like cars, factory smokestacks, maybe even airplanes. But what if one of the absolute biggest culprits is something we're in every single day? Our homes, our offices. Okay, let's get into this because today we are diving deep into the massive and often totally invisible climate impact of our buildings.
I mean, that's a pretty wild thought, isn't it? The idea that the very place you live your life could be a critical piece of the puzzle for solving the climate crisis. It sounds almost too big to be true, but the connection is incredibly direct. And it all starts with just understanding how our homes actually use or waste energy.
And to really get a feel for this, I want to share a quick personal story because it really hammered home for me just how much our modern buildings have turned into these giant energy hogs. So, I once lived in this super modern apartment building. You know the type, all floor to ceiling glass. It looked amazing, but living in it was an absolute nightmare. In the summer, it was literally a greenhouse. It was boiling hot, so the AC had to be blasting 24/7. And in the winter, an icebox. The heating bills were just through the roof. It was in a constant battle with nature. Now, compare that to traditional Korean Hanok architecture. Those buildings are designed to work with nature, using the sun's path and natural breezes to stay comfortable with hardly any energy at all. And we're not talking about a small difference here. Let's say that traditional Hanok, maybe with a few solar panels, needs about 50 units of energy. Well, that gloss apartment, it burned through 300 units. That is a 6 times increase. We're just pumping tons of energy into these buildings to fight against their own terrible design. So we have to completely flip that script. The number one rule, the most important principle of building sustainably, is just to reduce how much energy you need to begin with. That's what passive design is all about. Things like better insulation, smarter windows, designing the building to work with the sun. It's only after you've cut your demand way, way down that you should start worrying about efficient appliances or generating clean energy, right? I mean, you can't just slap solar panels on a leaky bucket and call it a day. And speaking of generating clean energy, some cities are creating these absolutely incredible tools to help people do exactly that. Let's take a look at a brilliant example from Seoul. So what if you could actually see that potential? That is the exact question that the Seoul Sunlight Map was built to answer. It's this amazing public tool where anyone can just type in their address and see right there on the screen exactly how much solar power their own rooftop could be generating. It's all about making clean energy visible and personal. And get this isn't just some rough guess. The map uses insanely precise LiDAR satellite data to build detailed 3D models of every single one of the 700,000 buildings in Seoul. It looks at the shape of your roof, the angle, and even calculates how shadows from that building next door will fall on it throughout the entire year. It's this incredibly sophisticated analysis that basically turns the whole city into a potential power plant.
So, what does all that fancy data actually add up to? Well, the map estimates that Seoul's rooftops have a total annual solar potential of 4,700 megawatt hours. That is a staggering amount of clean energy just waiting there, ready to be harnessed from surfaces that right now are just sitting in the sun.
Okay, so a tool like that is a game changer for a city. But now we need to zoom out because we need to see why this is so unbelievably critical on a global scale. And this is where the numbers get truly mind-boggling. All right, so if you take the energy our buildings use day to day and you add the emissions from actually constructing them, the building and construction sector is responsible for 39% of global carbon emissions. Let that sink in. That's more than all of industry. And it's way more than all transportation. We're talking cars, planes, and ships combined. This is the elephant in the room that we almost never talk about.
But here's the crazy part. Even that giant 39% number isn't the whole story. Not even close. To really understand the full picture, we have to look below the surface.
Okay, so the part that we all know and see is called operational carbon. It's basically the energy the building uses to run every day. It's the electricity for your lights, the gas for your heat. It's the number on your utility bill. It's the visible, obvious stuff. But here's the thing. All of that, the heating, the cooling, all of it, turns out to be just the tip of a much, much bigger iceberg. The real weight of the problem is hidden from view. This massive hidden part is what's called embodied carbon. This is all the CO2 that was spewed into the atmosphere just to create the building itself, to make the steel, to pour the concrete, to manufacture the glass. It's the building's carbon footprint that is already baked in the day it opens, before anyone ever flips on a light switch.
I mean, think about the entire journey. It starts with mining raw materials out of the ground, then transporting them, then manufacturing them into products in factories, then trucking them to the site, and then finally the construction itself. It's this enormous upfront carbon bill that's paid in full before day one. All right, so it's a two-headed monster, right? We've got the operational carbon we can see and this hidden embodied carbon. But the really good news is there are some absolutely brilliant design philosophies and projects that are tackling both. So to go after that operational carbon, you have something called the Passive House Standard. It's this genius design philosophy from Germany. And the wild thing is, it's not about adding a bunch of fancy tech. It's about getting the basics, the fundamentals, incredibly right. Like making the building totally airtight, using super high-performance insulation, and having smart ventilation. The goal is to make the building so efficient that it pretty much doesn't need any heating or cooling at all. And that right there, that's the whole ballgame. The future of green building isn't about just slapping more solar panels on top of everything. It's about a fundamental change in how we design from the very beginning. So what about that hidden monster, embodied carbon? Well, check this out. There's this incredible movement called circular construction. Take the K118 project in Switzerland. Instead of just demolishing old buildings and hauling the junk to a landfill, the designers treated those old buildings like a treasure chest. They carefully took them apart, salvaging things like steel beams, concrete slabs, and even whole sections of the facade to use in the new building. By doing that, they cut the new project's embodied carbon by over 50%. A project like this is just proof of a totally new way of thinking. It shows that a building doesn't have to have an end of life. It can be deconstructed, and all its valuable, carbon-heavy parts can become the beginning of something new. So what this all points to is a completely new mindset. We have to stop seeing our buildings as just passive shells we live in. Instead, we have to become energy farmers, harvesting power from our own roofs, and material harvesters, mining old structures for the resources to build the next generation of buildings. And that really brings us to the final and maybe most powerful idea here. You can't fix a problem that you don't measure. By understanding both the operational and the embodied carbon, we give designers real power. Because in the end, the designer who consciously works to reduce a building's carbon footprint, they're not just designing a building, they are literally designing the tools to help turn back the climate crisis.